I would like to introduce our first speaker of the session, Dr. Zeeshan Rahman. Dr. Zeeshan is Assistant Professor in Botany at Zakir Husain Delhi College, University of Delhi. He did his doctorate in heavy metal microbe interaction from Department of Botany, University of Delhi. He has hands-on experience of using various statistical analysis during his PhD research. Dr. Zeeshan has published his PhD research in various reputed journals. He has also been teaching biostatistics at undergraduate level in Zakir Husain Delhi College.
Hello everyone, my name is Zeeshan Rahman. The topic of my presentation is classification of data. Any research investigation can have 5 sequential steps. They are collection, classification, presentation, analysis and interpretation of numerical data. Of all these steps, collection is the most important step because if any error is in the collection of the data, all further analysis will also be affected. The second part, classification, is also very important because it provides the basis for further analysis. It can be defined as a process of organizing data. The data can be divided into relevant groups or classes for the simple understanding. The basic pattern of arrangement of data is in their resemblance and affinities. The main objectives of the classification is presenting the fact in simple form. It helps in comparing the components of a variable. It also helps in finding the relationship between different components of variable or between two or more variables. The high volume of data can be condensed into small tables. They are suitable for further statistical treatment. They can be used for the graphical representation. The classification of data implies conversion of raw data into an array data. This is the most elementary arrangement where a raw data is converted in an order of magnitude or in certain sequence. The example of raw data does not have any sequence. However, after the conversion of raw data into array form, they are arranged in the ascending orders. Based on the data type, classification can be of 4 different types. It can be geographical, based on the spatial pattern, chronological, based on the temporal pattern, qualitative, based on non-measurable characters, and it can be quantitative, based on measurable values. Based on the qualitative data, which are also known as attributes, the classification can be of 2 different types: twofold or simple classification and manifold classification. In twofold classification, the one attribute can be divided in a set of characters. Like the population can be divided based on the gender, marriage and wealth. All these examples are part of dichotomous branching. In a different example, population can also be divided based on different cities, which is an example of polychotomy. The manifold classification involves multiple divisions. The multiple divisions, the main attributes can be divided into one set of character, and this set of character can be further divided into another set of characters. In this case also, it can observe dichotomy or polychotomy. The first 2 examples belong to dichotomous branching. The last example is associated with polychotomous branching. Tabulation is an important part of classification. It helps in understanding complex numerical data in a simple and clear way. Tabulation is presentation of data in rows and columns. Other than rows and columns, the first vertical row is known as stub and the first horizontal column is known as column head. And the first cell of the column and row is known as stub head. The rest of these cells are known as table body. A table should be complete, compact, and self-explanatory. The title of the table should be at the top, caption and footnote should be at the bottom. If the table has taken from any other source, its source should be mentioned. Depending on the number of variables also, the table can be simple or complex. If there is only one variable, it will be known as a simple table. If there are more than one variable, they will be known as complex table. The complex table may have 2, 3 or many variables. Complex table form cross tabulation, which is also known as contingency table. In this example, there is only one variable. This variable is country and the content is COVID cases. This two-way table has two variables. These two variables are countries and the causes. These causes has two components, infections and fatalities. And the content is again COVID cases. This three-way table has three variables. These three variables are years, party and ideology. The ideology has three components and the content is percentage. The second way and third way table are forming cross tabulation where variables are crossing to each other. Likewise, more variables can add more branching in the table. That will be treated as manifold table. Based on the content also, classification can be of three different types. It helps in the representation of the data values in forming the frequency distribution. Another use of tabulation is in the formation of summary table. Let us consider an example of each type for better understanding. This table represents different variables and their values. For example, parameters like pH, EC, salinity, TDS, chloride, all of them are example of different variables. They have been measured in different water samples. These digits are representing the values in different units. This type of table is a part of presentation which helpful in comparison and identifying the relation. The summary table possesses statistical information of the data. In this case, the variables are weight of plant, types of plant, monthly input. They all are variables. Their count, mean, standard deviation. They are the statistical information. This kind of table is known as summary table. Frequency distribution is also a tabulation which displays the frequency of the characters or value of a variable in a given dataset. So the digits which are written in the cells are the frequencies. This type of tabulation is used when there is a large number of observations in the sample. The frequency distribution should possess some important characteristic. Exhaustive, that is, it should be possible to include each of the data points in one or the other group or class. The class must be mutually exclusive, that means there should be no overlapping. Based on the types of data, it can be of two different types. Frequency distribution for qualitative data and for quantitative data. In this example, there is a set of observation of 10 days of winter season. The presence of sunlight is a qualitative variable which may have two outcomes, sunlight and no sunlight. In the frequency table, these two components can be written as a character, sunlight and no sunlight, and their frequencies can be written side by side. Now let's take another example for the quantitative data. In this example, there is a set of observation of 10 days in winter, but the quantitative variable is temperature. Temperature can be measured in degrees Celsius or in other units. In this example, the temperatures are measured in integers. There are many repetitions in the values. They do not form any sequence. When the frequency distribution of quantitative data is prepared, the values should be written in an order. Mostly ascending order are preferred. In this case, the 9 degrees Celsius is the smallest value, which is written in the first cell, which is followed by 10, 11, 12 and 13, and their frequencies, their occurrence can be written side by side. The quantitative frequency distribution can be further divided into ungrouped type and group type. The ungrouped type of frequency distribution is useful when the values of occurrence repeat itself in multiple observations, and this has application mainly in the discrete series. Whereas the group type of quantitative distribution is useful for the large data set having wide range of values, and it has shown application for both discrete and continuous series. Let's understand these two subdivisions through examples. In the ungrouped type of frequency distribution, the exact values of the temperatures are written in the stub and their frequencies side by side. Whereas in the group type of data, it involves the grouping of values. The grouping of values is defined by interval, which is also known as class interval or. Let's consider an example here. Again, in the set of observation of 10 days in winter, the mean temperature has been measured. But in this case, this measurement has been taken in decimals. There was hardly any repetitions in the values. In this case, the grouping method is involved. According to size of values, each cell can have a range of values, and all the values which fall in this range can be taken as an occurrence in the form of frequency. A typical frequency distribution should contain 5 to 15 rows. It shouldn't be more than that or less than that. When there is a wide range of observations, you can make the table having wide range of class interval. Making wide range of class interval will fit all the observations in limited number of rows. Also, when there are limited number of observations in a data set, the width of the class interval can be small, which will add a sufficient number of class intervals. There are many technical terms in group type of frequency distribution which are important to understand. Class limit is the minimum value and the maximum value of a class interval, which can be called as lower class limit and upper class limit respectively. A class may have class boundaries, and this class boundary correspond to halfway point between two class intervals. Like lower class limit and upper class limit, there are lower class boundaries and upper class boundaries. Class mark, it is the halfway point of the difference between upper class limit and lower class limit. That is also called as mean of the class interval. There is a class width, which is also called as a range of the class. It is a difference between upper class boundary and lower class boundary. Based on types of class interval, group type of frequency distribution can be of two different types. Non-overlapping type of frequency distribution and overlapping type of frequency distribution. Non-overlapping type of frequency distribution is also known as discontinuous type of frequency distribution. In this type of frequency distribution, the class intervals are non-overlapping. If you see this example, first class interval starts from 17 and up to 19. The second class interval starts from 20 to 22. So there are no overlapping. In overlapping type of frequency distribution, there is an overlapping between first and second class. For example, the first class interval has a class limit from 17 to 20, and the second class interval has a class limit from 20 to 23. However, their class boundaries will vary. For the non-overlapping type of frequency distribution, the class boundary will be the midpoint or halfway point between two class intervals. So if we see the first and second class interval, the class boundaries are little bit extended from their class limits. However, in the overlapping type of frequency distribution, as there is already an overlapping between the upper limit and lower limit of preceding and succeeding class intervals, there is no difference between the class limits and class boundaries. The midpoint for both non-overlapping type and overlapping type of frequency distribution may vary, as it can be calculated as a difference between upper class limit and lower class limit divided by 2. But the class width for both overlapping and non-overlapping type of frequency distribution remains the same, considering the difference between lower class boundary and upper class. Here now let's take a logical example to draw a frequency distribution. There is a table of number of grain per spike in wheat. This table includes 130 observations. The first table, 1/3 of 130 observation, is raw data. The first step is to convert the raw data into array data. The second table represents in the array form, where you can see there are repetitions in the number. Since there is a wide range between 17 to 43, it would be difficult to make ungrouped type of frequency distribution, because it will require to write all the values in the column. This process will increase the number of rows. That is why the more convenient and the more compact way to form group type of frequency distribution. If you are going to prepare using ungrouped method, it will require 27 rows to form from 17 to 43. But the grouping method allows to condense this 27 rows to 10 or 12 or maybe for 5 rows. The group frequency distribution can be formed in two different ways: overlapping and non-overlapping type of frequency distribution. In the non-overlapping type of frequency distribution, the first class interval include the value from 17 up to 19, and the second class interval will include values from 20 to 22. However, in overlapping type of frequency distribution, the first class interval will also include the value from 17 up to 19. The upper class limit of this class interval, that is 20, will be included in the second class interval. So the second class interval will include the values from 20 up to 22, and the upper class limit, that is also the boundary for the overlapping type of class interval, will be considered in the next class interval. So this is the way for including different values in non-overlapping and overlapping type of frequency distribution. There is no fixed pattern to determine the number of classes and the class width. But in one way, you can apply a rule that is known as Stokes rule, which can help you to identify the number of group or classes using formula. This formula is K is equal to 1 plus 3.3 log 10 n, where n represents the total number of observations. As per this rule, if you take an example, total number of observations 10, the number of class interval will be 5. Applying this rule, you can keep 10 in the place of n, then it will be log 10. Log 10 will be, that is 1. You multiply with 3.3, 1, and it will give 4.3. You cannot make the number of class interval, that will be 4.3. You have to take the upper limit of to form an integral. If there are 10,000 observations in a data set, the number of class interval can be 15. Based on the number of classes, the size of the class interval can also be calculated, taking into account of the maximum values and minimum values. The other way to make frequency distribution is your convenience. You are free to choose the number of class intervals or the size of class. Any of these choice will ultimately bind you to select the other parameter. If you are choosing the number of class intervals, the size of the class interval will be determined by taking the difference between maximum and minimum value. If you have chosen the size of the class interval, then the number of the class interval will be limited according to the width of the classes. This type of convenience is selected as per the hypothesis. For example, if you are working on certain age of people, your focus is on identifying the characters at different age group, you can form the class interval on that basis. When the in of the first or last class interval is not specified, they are known as open-end class. The first example has one open-end class. The second example has two open-end classes. Frequency table can be used for various type of measurements such as cumulative frequency, relative frequency, and percentage frequency. Cumulative frequency is the total number of frequency fall above or below a particular class or value in a dataset. It can be of two different types, more than cumulative frequency and less than cumulative frequency. Relative frequency is the ratio of the frequency of a class or value to the total frequency. Percentage frequency is the multiplication of the relative frequency of a class with 100. Let's take an example to understand these measurements. In more than cumulative frequency, the lower class limit of the class is considered and all the frequencies are added. For example, for the first class, the lower class limit is 17 and all the frequencies above 17 will be included as more than cumulative frequency for this class. Similarly, for the second class interval, all the frequencies which are above 20 will be included as a more than cumulative frequency for the second class interval. Likewise, less than cumulative frequency is measured all the frequencies that is lying below the upper limit of the class interval. For example, in the first class, the upper limit is 19. All the frequencies which are below or less than 19 will be included in the less than cumulative frequency of that class. In the second class interval, all the frequency which is less than 22 will be included as the cumulative frequency of this class interval, which will include the frequency of first class interval as well as second class interval. The relative frequency can be calculated by taking the frequency of that class and dividing with the total frequency. And the frequency percentage can be calculated by multiplying the relative frequency with the 100. The summation of relative frequency will always be 1, whereas the summation of frequency percentage for all the class interval will always be 100. Another important use of frequency distribution is in measurement of frequency density. It is especially used for frequency distribution with unequal class interval. Frequency density is measured as the ratio of a frequency of a class to its width. Let us consider the calculation and application of frequency density through examples. The first table has same width for all the classes. Hence, their frequencies can be compared among different classes. Also, frequency density will be in the same proportions. However, when you consider the second example, the class width is of unequal size. The first and fourth classes have class width of 10, the second class has width of 30, and third class has width of 20. Due to difference in the class width, their frequencies cannot be compared. Taking this into an account, frequency density has a role to play which make the use of class width and frequencies both to bring information in same proportion for all class interval. Frequency density has an application for the frequency distribution table with unequal type of class interval. Thank you.